Now, when Newton wrote the Principia in 1687, he presented, of course, the three laws of Newton. He also discussed something which was an exception. He found out when he spun a bucket full of water and tried to apply his three laws, actually the second law, F equals ma, that it didn't work in certain situations. This is known as the Newton bucket experiment. So we start with stationary water in the lab frame. And remember, Newton is looking at this because he's standing stationary on Earth, and that's the lab frame. What you see after the water starts spinning with the bucket is a depression in the water in the center. You get a vortex, a whirlpool formed, and you can predict that that is going to happen by using Newton's law for centrifugal acceleration, mv squared over r. The rotating water is subject to this law. It predicts that there will be a centripetal force, and so the law agrees with the result. We predict that the water will be thrown up the sides by the centrifugal force, and that's exactly what we see. Now let's pretend that there's a person on the bucket. Call it a bucketeer. This guy can make measurements from his point of view. To him, the bucket is not rotating. He's at rest, and he sees Newton and the lab rotating around him. So as Newton sees the bucket rotating clockwise, this guy sees Newton rotating counterclockwise. And we know that the result is going to be the same. If you're on the bucket, you have to see the same thing. You have to see a vortex formed, a whirlpool. But if you apply Newton's law to the guy on the bucket, to him the water is stationary because the water is rotating with the bucket. So the speed of the water measured from the bucket frame is 0. So the guy on the bucket would predict that the water surface is flat, but it's not. So Newton's law does not work on the bucket. It does work in the lab frame. There have been a lot of things through history, a lot of attempts to correct this. Mach's principle, which was stated almost 200 years after Newton talked about this, that principle is quoted incorrectly by mainstream. I give you two examples there. Physical law relating motion of distant stars to local inertial frame. So Mach is saying in that sentence that it's the distant stars that are rotating that somehow influence the water in the bucket. This is called an inertial influence. In another place in mainstream, I quoted local laws are determined by the large-scale structure of the universe. Well, that means everything in the universe, including the Earth, contributes to the effect that we see, the rotation of the bucket in the Earth frame causing a vortex. Now, what I did was I looked at the sources. I looked at the book that Mach wrote, and what it says is such forces are produced by the relative rotation with respect to the Earth and the other celestial objects. So what Mach actually said is it's the rotation with respect to the Earth and the other celestial objects, which is not what is quoted in the mainstream textbooks.
Well, look at that.
So Mach did say,
dude, look at that.
Dude. Newton's bucket leads us right to the crux of the matter. Go figure.
Dude, it all comes back to a guy in his bucket, and we're all told about the apple that fell on his head. How about the bucket that the dude swung around and
I
realized?
always wondered, what story were they hiding with the bullshit about an apple falling on the head? It was the bucket story that they were hiding.
Dude, the bucket story. The bucket story.
I mean, that's a really straightforward, logical body bag.
Right?
I'm not understanding it. Is it that the water, the guy, he thinks he's staying still, but he's gonna look at the water, and the water is essentially gonna go up the edges of the bucket. So essentially, there has to be a difference between the moving and not moving frame, no matter what reference you're from.
It's all comes back to the speed being like c plus v. He's trying to do relativistic frames, right? We're talking about the resting frame and from wait, what the fuck?
I mean, I think that sounded about right. I think you're.
Yeah.
You said like all the frames have to be equivalent, but in one frame he's standing still, yet the water has to essentially make a hump on the edges, which isn't possible from a still frame, right? If you're not moving, should be.
Yeah, the example of Newton's bucket led us into this true derivation of Mach's principle, which he said was directly misquoted because the actual quote is the motion is derived from the spin of, not from the Earth, but from the spin of the other stars, meaning the ether. It literally quotes the ether spin, the ether wind that we talk about, the toroidal vortex motion that we all measure. That's what Mach's principle was directly quoting, and then has been perverted in mainstream to mean like completely the other thing. That's what he's pointing out, which is awesome.
Yeah, so real quick, back on the bucket prediction, the guy in the bucket, mathematically makes the prediction, but it's the wrong. It doesn't matter because we know that the bucket curves. So he can do the math equation and get 0 so that there's no water curve because he's at rest. But we know that that's not real. We know that that's not true. The frame's like invalidated by the fact that he's not actually at rest, and we can observe that the water curves when it's due to that motion.
Right. So he's kind of trying to compare
So,
that, like,
if the Earth was spinning, there would be a curve. There would be like a difference. There would be a difference between reference frames, essentially, given this bucket scenario. But they say that there's not.
Yes, they try and tell us that we can't tell the difference between Earth rotation and Earth not rotating. This is the difference.
right. So
This is why the Earth isn't rotating.
he was
This is
trying to,
why.
They're on the same. Dude, that's crazy.
Yeah,
trying
this
to
is
say,
what.
like, kinematically they're equivalent, dude, right? Like, kinematically you can say either or and it makes a difference, but dynamically it's always one way or the other, meaning it's always the Earth-centered frame, like always, Earth-centered, everything rotating around. That's why it matters.
Yep. And then to get into the Mach's principal quote, which has been bastardized, as Shane, eloquently put it, the source of the rotation is coming from the stars, right? It's not coming from how do they say it? What do they even say now? They just say that it comes from nothing, right? Just from. No, they say that it comes from the stars too. What do they? How do they misquote it again? Because I've never heard it.
Large-scale structure of the universe is what he said. It's determined by the law, which means it comes from everything. And he's like, that's not right. That's a perversion of the actual law. And the first way was the motion of the distant stars. So no, that's the right interpretation.
So I
what
think
was
you
the
had
other
it
fake-
backwards.
Yeah, hold on.
A lot of
Because it
attempts
says
to
mainstream there, yeah.
correct this. Mach's principle, which was stated almost 200 years after Newton talked about this, that principle is quoted incorrectly by mainstream. I give you 2 examples there. Physical law relating motion of distant stars to local inertial frame. So Mach is saying in that sentence that it's the distant stars that are rotating that somehow influence the water in the bucket.
Yeah, that sounds
This is
retarded.
called
When you say it
an
like
inertial
that, you're right.
influence. In another place in mainstream, I quoted local laws are determined by the large-scale structure of the universe. Well, that means everything in the universe, including the Earth, contributes to the effect that we see, the rotation of the bucket in the Earth frame causing a vortex. And what I did was I looked at the sources. I looked at the book that Mach wrote. And what it says is such forces are produced by the relative rotation with respect to the Earth and the other celestial objects.
Right.
So what Mach actually said is it's the rotation with respect to the Earth and the other celestial objects, which is not what is quoted in the mainstream textbooks.
So he says that the other celestial objects are caught up in that ether wind as we see them from Earth, not that they're the cause of it, right? Like, that would be weird.
Yep. Yeah, man. Pretty crazy.
So I mean, like, I think an example of something that would be like a dynamic effect of a rotating Earth would be, as between like the argument between Kepler and Galileo, like basically you should be able to go up to a high tower and drop something, and then it shouldn't land right at the exact same point below where, because the velocity should change, because when you're higher up, you're further from the center, so you should have a measurable different velocity at the top than at the bottom of the tower. So the rock should actually land in front of the tower with respect to the rotation. So just like as trying to illustrate like the bucket effect, how we would see that on a rotating sphere, that's something that we should be able to experience, is the difference in velocity as the altitude changes.
You would think there would be something, like literally something, but there's just not. And then even if when there's not, they'll say, oh well, it's moving in lockstep, therefore blah blah blah, conservation, blah blah blah. Like there's always something,
So wait,
to make the ball appear stationary.
What was the problem with Newton's bucket? Wasn't that like they want to like make them equivalent, so they equivocate and they go kinematically, look, we can describe them the same, and they go, nuh-uh, dynamically when we're doing this we can only have it one way, and they go, okay, we're gonna solve this, but they never solved it, and they've just been using that rule in heliocentrism ever since. Is that kind of what happened?
Yep.
Okay.
Yeah, because the mathematic framework that he came up with, like, I guess when Newton came up with, like, using this algebraic expression to kinematically express the celestial movements and stuff, right? That blew everyone away, dog. Everyone was like, "No way! Like, this is the craziest shit ever!" Like they, so like they weren't trying to give that up,
Yep. It makes sense now.
And it was all downhill from there. And they were like, "Yeah, but we can explain it in this frame." And like let's just not tell anyone.
It's why Galileo got kicked out of school, because he wanted to believe in this nonsense.
Well, there's some occult historicity to that, probably, which perpetuated which narrative and who was trying to drive which point home, for sure.
Yeah. Oh, here's a good summation of the Newton's bucket. Here's a great way to another way to look at it. Here we go.
That reference frame exists, but he didn't say where it was. Now, I tried to update this experiment by doing something that's more familiar. Newton's bucket, the experiment is named after him, so I'm going to call this Bennett's hiker. We have, first of all, a hitchhiker frame, which is the same as the lab frame. If you have a car accelerating towards you as a hiker, and you ask, what do the laws of physics predict? Then the prediction is the force on the driver, Fd, is equal to the mass of the driver times the acceleration. So Newton's law says the driver should have a force exerted on him. And we all know this is true. If you're accelerating in a car, you can feel the car seat pressing on your back. And you could measure it with the appropriate equipment. So if you are in the hitchhiker frame, which is the lab frame, Newton's law is correct. Suppose you use the reference frame of the driver. In the driver's frame, you see the hitchhiker accelerating towards you with minus a acceleration. And you want the force on the hiker to be equal to the mass of the hiker times his acceleration. All right, the calculation shows that this is not zero. But we know that when a car passes you and it's accelerating, you don't feel any force. You may feel a slight breeze from the air that's moving past the car. But unlike the driver, anyone stationed in the lab frame will not feel any force. This is exactly the same as Newton found, that only in the lab frame, stationary on Earth, can the laws of physics be properly applied. Kinematics is an important concept. It means...
Yeah, we're told a lot of things about Newton, but we're not told that, right?
That's a pretty good one. Whoops.
Yep. Yeah, man. So here's going to get into some kinematics. So again, some good rhetoric on the kinematics and dynamics and the differences between them. So this is good here.
Measurement. Kinematics means measurement. Kinematics means measurement. Kinematics means measurement. I said it 3 times because if you've heard something 3 times, supposedly that's supposed to be part of your permanent memory. How did kinematics arise? Probably the astronomers noted the motion of the stars, and they began to track it and to make up charts which would predict in the future where the stars would appear in the sky. So these circles became associated with...
right? They tracked the motion of the stars to predict the motion of the stars. They didn't track the motion of the Earth to predict the motion of the stars.
Very logical way of doing it, I'd say.
Right?
Measurements. And from that, we could interpret mathematical relationships. The acceleration of the stars must equal their speed squared over r. That's a consequence of the measurement. Galileo made measurements of a falling object, and he found that the speed of an object is proportional to the time, no matter what the weight of the object was. So he can generate from that a algebraic equation, a mathematical description of free fall. But all this is based on measurement. They're not applying any laws, except using the measurements to generate the laws. So this is a process of induction. The law of the pendulum, same thing. Observe a pendulum swing, measure its period, knowing the length and the acceleration of gravity.
What's that? Kinematic derivation?
Yeah, that kinematic derivation of G over there on his right hand and that little graph I can barely see on my tiny screen. That's what that's the same meme that Witsit uses all the time when he whips that out.
Oh yeah.
Well, it's a different depiction of the same equation.
You can calculate the period. So the law is generated from measurements. Now, an important concept here is relative motion is valid. In kinematics, if I were 5 feet north of you, then you would have to be 5 feet south of me. That's an example of relative position. Repeat that with velocities, accelerations, and so on, and you find that measurements always obey relativity. So relativity is true for measurements.
So again, in kinematics, measurements, repeated 3 times, so it's all in our permanent memory. the relative motion it's cool, it's great, right? So Einstein's whole entire framework of relativity, as long as it's not applied to anything real, it's good to go, right? So here's where we're gonna get into the distinctions.
Or we could say observer reference frame independence. Kinematics is arguing from specific to general, and it measures the quantity of motion, and that's why mathematics is applied, because all you get from a measurement is a number, and you have to use that number to predict things in the future. Now, dynamics is the other branch of physics. If you were to study physics, you would probably choose either experimental physics, testing, or you would choose theoretical physics, which is a prediction of future motion. The prediction of motion involves quantities that we discussed before, distance, velocity, time. In addition, you have quantities that are characteristic of whatever you're measuring. So mass, force, moment of inertia, charge, Q, all of these things are particular qualities of motion. In kinematics, you only trace the path or the trajectory of motion. In dynamics, you must include mass and force and other qualities.
I'm so glad that he's going into this now that I happened to call it out earlier, and he's going into explaining exactly what it means. That's perfect.
Yeah.
Relative motion is invalid, and we're going to show that. We've already shown it with Newton's bucket and with the hitchhiker experiment. The observer and reference frame dependence means that we have a lab or earth frame as an absolute frame. And we've used, as I said, the bucket and the hiker, and we will use an electromagnetic experiment, the Faraday experiment, to show that only the lab frame can be used in making predictions. So dynamics is always prediction, and kinematics is always measurement.
Predictions and measurements. Measurements and predictions.
It's like, hey, actually, the lab frame is the only thing that matters for measurements, predictions, real life, companies where money's involved. Anytime we do anything that's real, it keeps coming back to it. It keeps saying it. Actually, the lab frame is the only one we can use. Like, no kidding. So all these predictions for heliocentricity with all these other motions, that's all just what, like theory? And when it comes down to everything that works, say GPS and everything that has a measurement, everything for the military, then you actually go back to the dynamics and, Earth center, Earth friction, lab frame, resting frame. That's it.
Well, dude, think about this. They had to make Einstein's theory backwards compatible with Newton's stuff because it started off with like the lab frame dynamics, right? Like inertial rest frame. Sorry.
Yeah.
Like rest mass and all that, something at rest. It's like it had very clear definitions for all these things. And so when Einstein came in and was like, hey, mass and energy are the same, everyone was like, say what? It was a whole big thing because it was ruining this dynamic relationship of rest mass. So it was like, well, what the hell is mass then?
That's a very good point, right? Holy crap.
Dude, watch the E = MC² on Thursday. It's insane.